So now if you have f of 2, that means inside there, h of 2, I used h here. So that means we're going to have x squared, which is 2 squared plus 2, because our g is x. So that should give us what? A 6. So that's how you perform that. And then if you have h multiplied by g of 2, you're actually getting what? H of 2 multiplied by g of 2. So this multiplication, usually they will put it in dot. So please do not mix a composite function with the multiplication. So a dot is a multiplication, but if you are given an open dot like that, then it will be a composite function. So now that means h of 2 will actually be 2 squared multiplied by 2, which will be what? 4 times 2, which will be 8. So if you are given now, let's say you are given, let's say, h over g of 2, you're just gonna get what? H of 2 divided by g of 2. I'm just gonna erase that. So that means you're gonna get our h of 2, our h of x is x squared. You're gonna get 2 squared divided by 2, which is going to be 4 over 2, which will give us 2. And then finally, if you are given like now f minus g of negative 1, you're just gonna get f of negative 1. Let me say h here, I'm sorry for that. So because I'm using h of x and g of x, and then I'm gonna say here minus g of negative 1. So that means now I'm gonna have negative 1 squared and then minus negative 1 like that. So I'm gonna get 1 plus 1, which will give us 2. So that's how you evaluate those. So I think everything does make sense. Yes. These ones, right? I get you. I should have one here. I should have something here. There must be something here. Say they're putting T. How comes? Here is it. Can you see? Okay, let's perform that one and see if we're gonna get that 17. So how we can solve that? We have f of t is equal to into t minus 2 squared, right? And then we have g of t, which is equal to t plus 1. So now we have what? We want what? G composite f of what? Of negative 2. And then we're expecting to get that 17 there, if we are correct. Unless the solution here is wrong. So now what we can do now, maybe, let me just go back to my PowerPoint so that you guys can see clearly. So what do we have here? We have f of t equal to t minus 2. So I have f of t is equal to t minus 2 all squared. And then what we have again, we have what? G of t is equal to t plus 1. So if g of t is equal to t plus 1. And then here what they're asking now, they're asking us to find g composite f of negative 2. So that's g composite f of negative 2. So simple. We said that if we had just G composite f of x, that will actually mean that we take G and then we put f inside G like that. So if we now have what? G composite f of 2, what do we do? So maybe here what we can do, we can actually say G composite f of negative 2. Let's try that. Let's try that and see if it will actually work. So I think I understand why you wanted this question. I think I do understand. Let's try it like this. We are trying, right? So let's say we have our f of t, and then that is t minus 2 squared. So now let's say now we have what? F of negative 2, which will be equal to what? Negative 2 minus 2 squared. So that's going to be negative 4 squared, which is equal to 16. So now from here, let's see what we can do. If this is true, then that will mean that we put this guy inside that G. So we know that if our interpretation is fine, we are saying that G composite f of negative 2 will actually be G f of negative 2. That will mean now we'll put, because we know we already found our f of negative 2, and we know that is equal to 16. We just need to take that 16 and put it into what now? Into G. So that means we're gonna have what? But I think you guys already see that is correct. So we're gonna have what now? We're gonna have now inside of G we put that f of negative 2, of which that f of negative 2 is 16. And what is our G? Our G is actually t plus 1. Let me not put an equal sign here. So we say that we now get G of what? F of negative 2. In case that means that we put in place of t that f of negative 2 plus 1, and then our f of negative 2, that's the 16 we got. So it's 16 plus 1, which is equal to 17. I don't know if the person wanted this understood. Yes, I can even do a second example. Let's say, for example, let's just do a second one. Yes. Exactly, let's do it. So now let's say we have, and actually is what I did. Didn't I? Oh, I didn't. I used x. Okay. So now let's say G. Now saying that now if we are having G and then multiply by f of negative 2. Is this what you are saying? Or plus, ne? Same thing. Remember I said at first if you have G plus f of x, you will have G of x plus f of x. So if we have G plus f of negative 2, we'll have G of negative 2 plus f of negative 2, because that negative 2 is just in place of x. So that means our G now in this case was t plus 1. So we had our G, I'm just going to write here, as equal to G of x was equal to t plus 1. So we're just going to take G of negative 2, which will be negative 2 plus 1, and then that's going to be what? Negative 1. And then we take this, we put here. We say plus. We take what? F of, we know that our f of x was actually t minus 2 squared. Let me double check. Yes, we had 2 minus 2 squared. So now f of negative 2 we say now negative 2 minus 2 squared, which is going to be negative 4 squared, which is equal to 16. So we just take that 16 and put here. So we get a 15. That's the answer. Are you answered now?
Yes, I'm answering. But I also have a question on the multiplication. If we were to do the same thing and say G of
Let's change this to multiplication. So with multiplication, exactly. So that will just mean we are multiplying now. This is all that this will be the change that we have, and then we'll simply get a negative 16. The other one was a composite. That's what I was saying. You guys are confusing composite with the multiplication. So this one won't give us a 17 because we're multiplying the g of negative 2 with f of negative 2. But that one we did is actually that we find this f of negative 2. After finding it, we put it inside g. So exactly. This one is a multiplication. As I said, they will represent it with a dot like this. But if it were to be a composite, it will be like this. And then that will give you different answers, unless by coincidence. Exactly. Exactly. So, yeah. So I believe you guys now have a understanding. So someone wanted the division, the division of polynomial. So I think there's something important also we can address there before time ends. I'm just gonna take a random equation. So let's say now we have y, let's say you have x squared. No, let's say we have, let me do a simpler one first. Let's say you have x raised to 3 and then plus x squared plus 5x plus 2, and then we are to divide this, we are to divide this by x plus 1. So you know that if we're using a synthetic division, we're gonna have x plus 1, and then we're gonna have something like that. Sorry, that's actually, remember, for synthetic division, first thing we're gonna take this, and then we say that x plus 1 is equal to 0, a negative 1. So that means now we're going to have a negative 1, and then we'll do this, and then we take all the coefficients here, which is 1, 1, 5, and 2. I mean, can you see that we have the coefficients here? The coefficient of x squared is 1, the coefficient of x raised to 3 is 1, the coefficient of x is 5, and the constant is 2. Those are what we are taking. So now from here, we can now, what the first step that we do, we say bring down the 1 as it is. So I'll bring down this one down as it is. So what I'm gonna do, I'm gonna take the 1 and multiply by negative 1. I'm gonna get what? Negative 1. I put it under the second number there in the second column. And then now I'm gonna say this 1 plus this negative 1 here, and then I'm gonna get 0. And then from here, gonna say 0 multiplied by negative 1. I'm gonna get what? I'm gonna get 0. I put it under the following one. And then I say now 5 plus 0, which will give me 5. Then again, I say 5 multiplied by the same negative 1, I get negative 5. So negative 5. And then I will say 2 plus that guy, it gives me a negative 3. So now that means that now these 3 will actually represent my quotient, and then this one will represent my what? My remainder. So now to prove if we are correct, okay, after doing like this, guys, you can just put it like this. So since our highest power, our highest exponent there, can you see it was 3, right? So after dividing, you should move from 3 to what? To 2. It was 3, now it will move to 2. So that means this one here will stand for x squared, and then this 0 will stand for what? For x. So we have plus what? 0x, and then plus, am I doing the right thing? Yes, plus 5. This is what we have as a quotient. And then maybe to put it fully in a full form, you can actually take the remainder and say minus. The remainder is -3. You just divide that by what? By x plus 1, which is what we're dividing with. So in an actual note, this is your final answer. So you can actually, you know that 0x is just 0. So you actually just have x squared plus 5. So guys, how can we prove if we are correct here? So we can take this. We can take this. You see, we're taking this, what we got. And then we substitute there a 3. We're substituting what? Any number. But I'll just suggest that you substitute 3. Don't ask me why. Ask me later. Maybe after the test. So we substitute 3 here. And then we take that original equation that we had again. So we take this equation here again, and then we substitute what? We substitute 3 again. So when we substitute 3 here and here, because we know that this and that is the same thing, so we should get the same number. What I mean that they are the same thing, what do I mean by that? Is that if you have 5 over 2, you get what? 2.5. So that means 5 over 2 is the same as 2.5. 5 over 2 minus that 2.5 will actually be 0. So we're having the same thing, actually the same quantity. So if you have, let's say, 10 over 2, you get 5. 10 over 2 is 5, 5 is 5. So it's the same thing. So that's why now we have to prove it like that. So now that means if we substitute any number there, let's say, let me use a different thing so that you guys can see. Let's say now we are substituting here a 3. So you're going to have 3 raised to 3 plus 3 squared plus 5 times 3 plus 2. So that means what are we going to get there? What are you guys getting? I get 53 here. And then I'm going to substitute the same 3 here in this equation. So I'm going to get now what? I'm going to have what? 3 squared plus 5 minus -3 over 3 plus 1. And then tell me what you get there. Actually, I'm not getting the same answer. Is our answer correct? Question. Guys, didn't we make any mistake? Yes.
I think when we use this,
Yeah. The remainder must be 0, ne? I think I remember what you're talking about. You see, I want people like you. So, what do you get when on your side? What do you get?
I didn't do it.
The last number must be 0. But it actually, I get what you are saying. I get what you are saying. So, what do you mean? Do you mean I remember what you are saying. I remember it, but okay, let's do like this. Let's do like this. We'll go back there. So we are doing a practice for the test. So x raised to 3 plus x squared plus 5x. So we have x raised to 3, and then I have plus x squared, and then plus 5x, and then we have plus 2. Now we're gonna do this using a long division method, which is gonna be equal to, now we have here x plus 1. Let's do this and see what we're gonna get. So now x divided by 3, that should be x raised to 3 divided by x, which is this one. That's what we do. So we get what? X squared, and then that x squared we actually put it here. And then now we're gonna say x squared into x plus 1. So x squared times x, that should be x raised to 3. X squared times 1, that should be plus x squared, right? So now we go and subtract. X raised to 3 minus x raised to 3 is 0. And then x squared minus x squared is 0 again. So now, after getting this, we're actually going to say now 0 divided by what? Divide by what? Divide by, hopefully I didn't forget anything. Okay, 0, let's say 0 divided by x. So that's giving me, that is giving me 0. And then now if you say now 0 into, 0 into x plus 1, that should just give me a final answer of 0. So that means if it's giving me a final answer of 0, maybe you can just say 0 here. So either way, that 0 will not make a difference. So what we can do, we can just bring down this 5x now. We can bring down this 5x. And then now what we're gonna do, we're gonna say 5x divided by x, which is gonna give us what? A 5. And then we put that plus 5 there. And then now we say 5 into x plus 1, that should give me a 5x plus 5, yes. So that means here I'm having 5x plus 5 like that. And then I will need to bring down a 2 here, like that. So now from here, I can say 5x minus 5, that should be 0. And then 2 minus 5, that should be negative 3. So you can see now that this is our answer, this is our quotient, and then this is our remainder. So now, if that is the case, that means, let's check what we got at first. Our quotient was x squared plus 5, of which we still got that x squared plus 5 because of 0 there. And then our remainder, we got what? A negative 3, which we still got what? A negative 3. So that means that confirms that we are correct. So the only problem that we could be having is that when I write this final answer, I might have made something wrong. But that confirms that we did our synthetic division correctly. Do we agree, madam? So in an actual note, that means I have x squared now plus 5. And then I have plus. That should be negative 3 over x plus 1. Maybe then my way of proving it does not always work. Wait, why did I say minus at first here? Let's see, let me substitute that again. Let me substitute that and see. So I have 3 squared, 3 raised to 3 actually, plus 3 squared, and then plus 5 times 3, plus 2. So I still get 53 there. So maybe my way of proving I have made a certain something is not right, because here I actually get a 53 over 4. So what could be the problem, guys? What do we blame? Who do we blame, me or what? Anyways, as long as our answers are correct, so that is the way we write the final answer. This final answer should be written like this. That way is actually correct. It's actually correct. So unless you guys have any questions. So the people who said they want they want this division of polynomial, are you guys fine now? Okay, it's like you guys are sleeping. I'm just gonna do a last thing now, last thing, last one. So, and then I think from there would say we are actually done. So that is the application of